7.8 has to do with phase shift. We hadn't talked about phase shift yet. So this is like the last part of graphing that we're going to look at is the idea of a phase shift and curve fitting. And you have to know how to do this curve fitting for the second application problem, which I'm going to give you next time and give you, almost 2 weeks to do that because it's got quite a bit of challenges to it. And you have to know how to do some of the stuff that we're going to learn in this section. Okay, so first of all, this right here I just noticed is supposed to be cosine. You might want to change that to a cosine right there, okay? So these are just kind of the general forms that we're going to look at now. This would be every transformation that's possible now. So we've already learned that A is the amplitude. We've learned about that. Omega gives the period. We've learned about that. What we're really adding in new now is this C, which is called a phase shift, and that just moves the graph from side to side. It's like left to right, and that's it. So a couple things I want you to fill out. What was the general formula for finding a period of a sine or cosine? Where did you learn that? 2 pi over omega. And omega is absolute value. Just remember that you have to have a positive value on that, okay? The amplitude, what letter gives you the amplitude in these equations? A, okay? Amplitude is the absolute value of A, which what does that do? Stretches and shrinks the waves this way. Okay, so that's what that's doing. Now the phase shift, that's what's different now. That's what this C does. So what it's doing, if you have an X minus C, we're going to say that that represents a phase shift. You need to write phase shift as C in this formula. So we're going to say that that is a phase shift. Okay, and go back to kind of college algebra. Like for instance, if you had something like this, this is the kind of thing that you would have learned in college algebra. Say you had a parabola. And say that you had instead x minus 2 to the second. How did that 2 affect it? Which way? That way. Okay, it's almost backwards of what you think it's going to be. So if that's a minus sign right there, that's going to be a phase shift of the right C units, like that. Okay? Now this one was obviously supposed to say x plus C, so you need to change that. So that represents a phase shift. And that's going to go to the left, C units like this, okay? So that's what the phase shift is. That's the new part of this section, and it's actually the only new part of this section, okay? All right, what does the D do to this thing? We've already talked about that. Up, down, good. So if it's plus D, what does it do? Which way? Up, and if it's minus, it's going to go down like that. So basically, that's everything that we're putting together now. So really the only new thing that I'm really adding in here now is just that C thing, which is your phase shift, like that, okay? So that's what we're going to do. First of all, we're just going to look at some functions and identify the stuff before we start graphing, okay? All right, so I'm going to move this down just a little bit here, and let's do these last two problems kind of together. Now, the first thing that's real important on this is these things need to be in a factored form. Okay, what I mean by that is this number 3, that has to be factored out like this. Okay, so what you're going to have is when you put this in a factored form, you're going to have y equals negative 3 cosine, and then you're going to factor this 3 out like this. Okay, this what I'm talking about is factor that out so that you have a set of parentheses. If you don't do that, you're not going to identify the phase shift correctly. Okay, so you're going to take the 3 out, write that as x. Then you got to figure out what goes here, okay? So what you always do is you take this number, that pi over 3, and you always divide it by the number that you're taking out. You always factor out what's in front of x, nothing else. So how do you divide a number by 3 anyway? You multiply it by a third, right? Okay, dividing by 3 is multiplying by a third. So what goes there is pi over 9. 3 times 3 is 9, okay, right? Okay. So it goes like that. Now that's called the factored form, and notice on this you want to be able to just kind of check this in your head. See, 3 times x is 3x, and isn't 3 times pi over 9 just 3 pi over 9? So it reduces to pi over 3? Okay, so one of the things you want to do is you want to factor and make sure you factored right. Okay, now we're ready to identify everything. Okay, most of this we already know. What's the amplitude of this thing now? It's 3. Okay, it's this number right here is the amplitude. Okay, so it technically is always a positive number, so we know the amplitude is 3. Okay, that's what that is. Okay, what's the formula for finding the period again?
2 pi
2 pi over omega. What is omega in this problem? That number right there. It's the number in front of x. Okay, so what's the period? 2 pi over 3. Good. Okay, so we got that. Okay, now, phase shift. Which number is the phase shift? Pi over 9. Okay, right? That's your phase shift. And which way is it going to go, left or right? It's going to go to the right or left? Left. Good. Okay, all right. That's because it's a plus sign. Now, typically what we're going to do on that is, since we're phase shifting to the left, you go ahead and write negative pi over 9. That's just because really the form is supposed to be x minus the phase shift like that. Okay, then that's going to go to the left like that. Okay, do you think this problem has a vertical up-down transformation anywhere to be seen? Yes or no? No, because what would you see? You would see like a plus or minus number at the end, so it does not have one. Okay? That's the idea. Now we've kind of learned every single kind of transformation there is. What does this negative do, by the way, right here? That reflects over the x-axis. Okay, so see, now you've got everything that's possible put together there. Okay? All right. Let's do one more like this and just kind of put this all together. And see, the mistake that students make on these problems a lot of times, if you're not paying attention, a lot of times students want to think that pi over 3 is the phase shift. It is not. Phase shift, you have to be in a factored form, so the correct phase shift is pi over 9. That's why you got it. If I give it in the factored form, then you're going to know that automatically. Otherwise, you got to put it in a factored form. Okay? All right, number 3, let's put this in a factored form. So we're going to bring down the negative 5, minus 2 sine, draw a big bracket, and factor out the 6. Okay, so when we do that, we'll have 6 times x. Now what you always do is you just take that pi over 2 and you divide that by whatever you're factoring out. So you're factoring out that 6c. So what you do is you do pi over 2 times 1 over 6. So what's that going to be? Pi over 12. Okay? And definitely you always want to try, check. 6 times x is 6x, so that checks. And then that's 6 pi over 12 when you multiply that, so that's really pi over 2, isn't it? Okay, check. Okay, what's the amplitude on this problem? 2. Amplitude is absolute value of that number. Okay, so we would say, you can do that in your head, just want to stress that it's a positive number. Amplitude's a distance, therefore it's positive, okay? The period we know is 2 pi over omega. What is omega in this problem? 6. Okay, there's your omega value. Okay, so we would say 2 pi over 6. So that's going to reduce down to pi over 3. So that is going to be your period, like that. Okay, so we've already kind of learned that stuff. Now, what is the phase shift? Is the phase shift pi over 2 or is it pi over 12? Pi over 12. It's got to be in the factored form. And which way because of the plus sign again? To the left. Good. Okay, so we're going to say negative pi over 12. We just say negative pi over 12 because it's a left. Now, what does this minus 5 right here do? That moves it down 5. It doesn't matter where it is. A lot of times students get confused in the front. It doesn't matter. Okay, you could move that minus 5 to the other side, so that's going to take everything down 5 like that. Okay, so that's the first thing you got to learn in this section is how to take a function that's in a standard form and find all the transformations. Okay, everybody got that okay? Okay, all right. So I'll move to the next page here. All right. Go ahead and see if you can do number 4. I'll give you a minute or two to put it all together. Start by doing the factored form, and then identify all the parts, and we'll learn how to graph these things. And the graphing is kind of what I'm trying to get you to do for the most part is to try to get to a point where you can do most of this in 1 step, maybe 2 steps, where you don't have to just do step by step. You can put it all together if you do it the right way, basically. Okay. Everybody see this okay today? Okay, isn't this cool? I just think this is awesome. Okay, what's the period? Hold on, what's the amplitude? Let's start there. 4. Okay, amplitude's 4. That's that number. What's the period? 2 pi over 3. Okay, that's omega. So that would just be 2 pi over 3. What's the phase shift? Pi over 3, which way? To the right. Is there a vertical translation? No. Okay, this time we didn't have like a plus or minus number at the end of it like that. Okay? That's everything. Is there a reflection over the x-axis? Yes or no? No. There would have to be a negative in front of the 4, right, in order for that to happen. Okay? That's step 1 in this section, is to know how to find all the parts of it. What's the only thing, again, that's new is the phase shift. So what this is saying right here, you don't really need to write anything on this. If you're going to graph something that has, a change of period and multiple transformations, you always want to start these problems by doing what we just did. Identify like the period, the amplitude, phase shift, vertical translation. Identify whatever you have. When you find the period, this is something we've already talked about, divide it by 4 to figure out how to break up the x-axis in an effective way. And then this is a real key thing right here. This is one of the real keys to doing this, is start at the phase shift. Okay, so when we actually try to do this in 1 or 2 steps, you're going to end up just putting your first dot on the phase shift. And if you do that, it keeps you from having to do a table of values. You can do a table of values if you want to, but it's really not necessary once you go through this step-by-step process to get this then. Okay, so I'm going to move this down, and we'll go ahead and we'll do our first graph here. Okay. Okay, so step 1 on this problem, again, is to put this in the factored form so you can find the phase shift. Okay, so when we do that, we're going to say y equals 3 times the sine, and we're going to take out that common, it's not a common factor, it's just you take out whatever's in front of x. Okay, what goes in the blank right there? Pi over 2. It's always this divided by that. A lot of times you can do it in your head. If you can't, you go to the side and crunch it out. Okay, so that's what we have. Okay, factored form done. What's the amplitude? 3. What does that do to the waves? Stretches this way, and that's going to multiply all the y values by 3. So that's what's going to happen. It's not a bad idea to put this in here. It's just that, again, we know it's the amplitude, but what it does is it multiplies y values by 3 so they get bigger. That's why they stretch vertically. What's the period? Pi. Good. Okay, it's 2 pi over omega. Omega is 2, so it's going to be pi. So we got that. So we have a change in period. What's the phase shift? Pi over 2. So that's your phase shift. And that's going to be pi over 2 to the right. And then this particular problem does not have a vertical translation. It doesn't have a reflection, so we've identified everything we need. Okay? Got everything. We've got the amplitude, period, phase shift. Now we've got to put it all together. Now, the next thing you always do is to figure out how to break up your x-axis is you take the period, which is pi, and you divide it by 4. So that's going to simply, what that's going to tell us is how to break up the x-axis in an intelligent way to make this problem as simple as possible. Okay? So what I want you to do next, we're going to go ahead and maybe do this, just kind of bring this out like this. Go ahead and just start getting your x-axis put together. So you're going to start at the increment, which is pi over 4. Then you just kind of keep counting it out like this, and you probably have to reduce fractions. So you're going pi over 4, then you're going 2 pi over 4, 3 pi over 4. You don't have to write this down. I'm just writing this down more for reference. Then you have 5 pi over 4 and so forth. So this is really going to be pi over 2. Then this one's going to be 3 pi over 4. This one, the 4's cross out, leaving you pi. And I'm going to go out one more. I mean, you don't have to, but I'm just going to take it out. You can take it out as far as you want to. Okay? Then let's go ahead and let's go backwards with this, because these are going to be the key values that are going to get us a really nice graph that'll make it real easy to do without touching our calculator or even taking the time to look at the unit circle. That's how good I want you to learn how to do this. You shouldn't have to even look at the unit circle. Okay? Now, how high should I make the y-axis on this problem? 3. Yeah, I got an amplitude of 3. I don't have a vertical translation that'll move that up, so it's very logical to just go up to 3 and then maybe down to -3. Okay, like that. And then we'll start kind of going through now and putting this together. Okay? So we're all set up and we're basically ready to go with this now. So we're going to do this in a couple of steps. Now I'm going to go down. I need to look up here and see what it is. I always forget what the function is that I'm doing. Okay, so we got 3 sine 2x minus pi over 2. What was it? See, I already forgot. Look at my short-term memory. Sine 2. Thank you. X minus pi over 2. Okay, that's what happens when you get old. Okay, so that's what we're graphing. Okay, so what we're going to do now is we're going to put it all together. Okay, the thing that you want to really do on this is you can learn to do this all in one stage, and that's what I'm going to try to teach you, is how to do this just in one stage. So I'm going to just look at this. Okay, where does a sine wave start? A basic sine wave, if I just had you graph y equals sine x, where does it start? At the origin, 0, 0. Okay. Now, like I said, that would be your first starting point, but we're going to phase shift it to the right pi over 2. So that point moves there. That's where it is. It's no longer there. Okay? You start with the phase shift and it'll make the problem very, very easy. I'm not kidding. Okay? Now, where does the sine go next? Does it go high, low, where? It goes high. Okay, so the next point on a basic sine hits the high point. Well, it's going to phase shift over there now. Okay, like that. Okay. However, what is the 3 going to do to that y value? It's going to stretch it up to 3, right? Okay, what that's doing is it's multiplying that y value of 1 by 3, so it moves up there. Okay? And we've already got 2 points, and that's enough. If you know how the pattern goes, then we've got enough. So what we've done is we've taken a basic sine wave, starts at the origin, phase shift it there. Okay? Second point's the high point, move it there, but stretch it up to 3. Does that make sense what I've done in my head? Okay, where do you think the next point's going to go? 0. It's going to go back down to a y value of 0. Okay, and then how about at 5 pi over 4? It's going to stretch down to -3, like that. Good. So what you have done now is you've done one period of that graph like that already. Okay, it's already done. Okay, so you can learn to do this, and of course if you go backwards through this, then it's going to hit the minimum there, and you can cycle through as many points as you want to. Then it's going to go back up there, back to its max, back like that, and then just sketch it. And then we have a beautiful, perfect graph. There are several periods on this. You didn't have to do that, but I wanted to just show you that idea on that then. Okay, problem done. Okay, you guys follow how I did that without having to do multiple stages? The whole key was starting at the phase shift. Okay, once you start at the phase shift, so you've already done the period change. What did the period change was figuring out those increments. That's what that does. Then starting at the phase shift, and then all you got to do is consider that amplitude, so then you got it done. Okay, now let's go ahead and let's do one check. I like to kind of emphasize this on the more complex graphs. You can tell you're right on this. Now what I'm going to do is I'm going to pick a point on the x-axis and I'm going to check it. Here's the one I'm going to choose to pick because it's probably the easiest one. I'm going to take that pi over 2 and I'm going to plug it in to the function just to show you what happens. Okay, this is a real good thing to learn how to do. If you're doing a quiz or a test or homework or whatever, if you want to find out you're right, all you really most of the time got to do on these problems is maybe verify one point. So if we plug that in, we would have 3 sine 2 pi over 2 minus pi over 2. Do you see why I chose pi over 2? Because it's 0. Okay, 0 is my favorite number to calculate with because it's so easy. So what do you have? You have 3 sine, and that whole thing's 0. You can do it in your head, right? Okay, suppose you forgot what the sine of 0 is. Don't go reaching for your calculator. Think about the unit circle. What's the sine of 0 based on the unit circle? It's the y value, right? Okay, so what you would have is 3 times 0, which is 0. That's what the y value of that point is, so it checks. Now you could do that with as many points as you want to. to me, if you check maybe 2 points and you have the shape, then you got it, don't you think? So you can tell you're right on these problems. That's a real important thing, and it also kind of helps you understand what's going on in the problem better anyway, okay? So do you guys got any questions about how that graph was put together? Okay, the only thing that we're adding on that now is a phase shift. That's the only brand new part of this problem that we're really looking at, okay? All right, any questions? Okay, so the key is if you have a phase shift, that's where you start. That's what your first point is that you should identify, okay? All right, so we're going to do a few more of these. Now, if you look at number 7 on here, number 7 is already in a factored form. See, I've already got that 4 factored out of there, okay? So let's just identify everything that we have. So what's the amplitude on this problem? It's a half, right? Okay, that's that number in front. Okay, the period is 2 pi over omega, and of course omega is that number. Okay, reduce that fraction to pi over 2. So what's happened is the period on this is kind of shrinking this way, going inside. What's the phase shift? It's pi, yes. Okay, that's the phase shift. So we're already in a factored form, and that's going to go to the left because of the plus sign. So we're going to say, since it's going to the left, you want to use negative pi. Then we'll just say it's to the left, okay? Does this thing have a vertical translation? Up 2, good. Okay, that's what that plus 2 is doing, is that's what's taking you up 2 because it's adding 2 to the y values, okay, like that. Okay, so we got everything kind of identified. Now what you always want to do is take the period, which is pi over 2, and you want to divide that by 4. Of course, that would be the same as doing pi over 2 times a fourth. So that's pi over 8, and that tells you that that's how you're going to do your x-axis when you put it together, okay? All right, so what we have is we have everything we need. We also might want to make a point on this that what's that negative right there going to do? It's going to reflect over the x-axis, okay? So I didn't have a blank for that, but it's important that we pay attention to that. So we're going to reflect over the x-axis. So really this problem has every type of transformation that I'm going to teach you. It has period change, reflection, amplitude change, phase shift, and a vertical translation. It's got everything. So if you can do this, then you've got it all put together, okay? What we're going to do now is I'm going to write this down here, and then I'm going to go ahead and have you draw out a graph. So you need to just draw yourself your own x and y coordinate system. I kind of got brackets and parentheses messed up, but it doesn't really make any difference. Okay, so we're going to get that all put together. Okay, so I'm going to slide that up a little bit. Then I'm going to go ahead and put together a coordinate system. Isn't that cool? Gosh, that's so cool. All right, so what we have here now is we're going to count by pi over 8. Okay, so start here at pi over 8. And then just keep counting. The next one would be, the next increment is 2 pi over 8. 2 pi over 8 is really pi over 4. Then it would go to 3 pi over 8. Then 4 pi over 8 is pi over 2, which is really the end of the period on that. Okay, now I'm going to keep taking this thing out a little bit here. There's a reason why, and it's because we have a phase shift to the left on that. Okay, so you could take it out that way, but since we're going to phase shift to the left, we need to really move everything to the left here a little bit. So just use these same increments, but let's see if we can go all the way out to pi. Now you can reason out without having to do this, but this is the way I want to choose to do this. So let's go negative pi over 4, negative 3 pi over 8. This would be negative pi over 2. Then it would be negative 5 pi over 8, negative 6 pi over 8, negative 7 pi over 8, and then all the way to negative pi, like that. So this one is really negative 3 pi over 4, like that. So I need to carry that out like that. It's just simple when you learn how to do this, just make it all the way to the phase shift. Now, I'm not going to give you something with a phase shift of 1,000,000. If you had that, you wouldn't obviously want to do it this way. But just to kind of get us started on this, I want to get everything put together. Okay, think about your y-axis. what do you think the maximum value, based on that number 1/2 and that number 2, what do you think the maximum value of this graph is going to be? Shrinks to a half, but then it moves everything up too. So what do you think? 2.5, exactly. Okay, so what we need to do is probably maybe go up to 3. Okay, like that. And then you can just put like, 1, 2, 3 like that, and then maybe a little mark to show that you're in half, and then go -1, -2, -3, and so forth like that. So of course, once you get everything identified, then you want to get everything set up right. Okay, get your increments written out for the x and y axis, that like that. Okay. Now, what you typically do, and this is the thing that I want to really emphasize as you're learning how to do this stuff, you really want to focus, if you want to do this in more than one step, and this one might be a little bit difficult to do in one step, although it's doable, is focus on what I highlighted, and don't focus on anything else, because if you can get that written down, then it's easy to finish up with the amplitude change, reflection, and up to thing. Okay, so watch how I do this. I'm going to do this like I'll pick a color like red, and then we'll put this together. Now this is all you got to know. Where does the cosine start? If it was just basically y equals cosine x, where does it start?
0, 1.
0, 1, exactly. So let's just kind of, in our mind, think of that point right there. That point right there is going to phase shift to the left pi units. Okay, so in your mind, you just move that point all the way over here. I'll put a dot there. Okay, now, what we're going to do from this point is we're going to cycle through all the key points. Okay, the second point on the cosine goes down to the midpoint, doesn't it? Okay, we're not doing any vertical transformation or anything yet, so just do that, cycle through the min, and so forth like that. We're just kind of doing we've done the period change, and we're not gonna take this to the end. Let's just basically go negative pi to 0 like that, and scale that in kind of like that. And then that will give us a function that we are going to transform to get the final result. Okay, so again, what I did is I took this point right here and phase shifted it pi, then I cycled through the cosine that we know. Okay, does that make sense? Okay, all you got to remember is cosine starts at 0, 1, move it over, and then cycle through like this. Now, what you do next is this. That -1/2, what it does is it multiplies y by -1/2. What the 2 does is it adds 2 to the y value. So you might as well just do arithmetic on this. That way you take care of the whole thing essentially in one more step. And to me, this is the simplest way to learn how to do this. Okay, so I'm going to kind of write some of these things down at the side right here. What is the y value of this point? It's 1, right? So what are you going to do? You're going to do -1/2 times 1 plus 2. And that will tell you where that point goes to. So that is actually, if you work it out, 1.5. It's 2 minus 1/2, so it's 1.5. So this point right here is going to go up to 1.5, like that. Okay, that's done. Okay, just by doing the arithmetic. Okay, what's the y value of this point right here? 0, right? Okay, so do this. Do -1/2 times 0 plus 2, what's that? 2. So that means this point translates up to 2, like that. So you want to get that kind of put in like that. Now we're done with that. Okay, let's go to the next one. This y value is -1, so do -1/2 times -1 plus 2. Well, that's really 2.5 if you do that. Okay, that's just 2 plus 1/2, so that's 2.5. So this point is going to move up to 2.5 like this then. Okay, so that kind of gives you enough points to probably figure out the rest, right? What do you think the y value is going to be of this point? It'll be the same as this one, right? Same arithmetic, so that's going to go to 2. Okay, how about this one? This one would be the same as that point, so that's going to go to 1.5. Like that. So see, now we're kind of getting everything pieced together. And then just kind of cycle through it. Now it's going to go to the midpoint. I might be getting off track here a little bit. I think I'm okay. That would go to 2. Okay, this one would go up to 2.5. This one would go back to the midpoint of 2. Then that would go back to 1.5. So that would cycle you through 2 periods of the graph like that. You guys see that last stage of the arithmetic I did? Okay, remember, you always, the last thing you want to do on these problems that have a bunch of transformations is if you graph what I've highlighted, then all in the world you got to do is take the y value of the points that I have in that red graph, multiply net by -1/2, add 2, then you got it. Now, you guys can see that it was reflected. Can you see that okay? Can you see that the amplitude shrunk? And you should be able to see that it moved up too. So it's done everything that you expected it to do, okay? All right, let's do a quick little check on this. Yes, go ahead.
I'm confused about the x minus -pi thing at the beginning.
Okay, now that is the phase shift. That's the new thing we're learning. So if you have in parentheses x plus something, it's taking a phase shift to the left. So what I did is see the original cosine wave starts at 0, 1, right? So instead of starting there, move that point over here. That's what I did, is I just took a basic cosine and I moved that point there. Then I started cycling through the way I know the cosine cycles. So that's what I was saying, is always start at the phase shift.
But what I'm confused about is at the very top of the page, well, you went from x plus 2 and made it x minus negative, or sorry, x plus pi and made it x minus -pi. I understand that you can break down positive into minus and negative.
Right.
But then you have -pi is a left shift. Negative
it is, and that's what I did. And you're saying that correctly, because you could write that part right there as 4x minus -pi. So that phase shift means that you're going to the left pi units. And that's exactly what I did. If you had a basic cosine, I mean, if I just had you graph y equals cosine x, doesn't that start at this point right here? Okay, that's what I did. I moved that point to the left pi. Okay, because that's where my increment is, all the way over to -pi. So I started there, then I cycled through the cosine wave through like that. And that's how it goes. And then once you get that, then you're going to work with the amplitude and the up transformation like that. So what you want to do is you want to start at the phase shift. Always start there. Okay, if it's left, move left. If it's right, move right. Okay?
But you're saying it's x minus pi should shift it to the right, but you're saying it shifts to the left.
Yes, that's because that's a plus sign. That's the way it goes. That almost,
that's -pi.
now that almost is, a lot of times students, that seems opposite of the way it should be. That's not the case. The general form is x minus something, okay? And if you write it in that general form, then that's the phase shift. So your phase shift is -pi, it means you're going to the left, okay? The thing that you guys would have learned in college algebra, hopefully, is like if you had something like this. That's a quadratic, that's a parabola, right? What did you learn about this? This way, right? That's a left 4, so this is the same thing, it's left pi.
Right, but why is it written under phase shift? Why does it say -pi?
Because because it's a left phase shift. So if it's a left phase shift, you want to put a negative. And again, the reason, and you said this, I heard you say this, is you can write that as x minus -pi.
Right.
So that's what it is it's -pi. The general form is x minus something, okay? All right? So see, it's kind of like this. If you had something like x cosine of x minus pi over 2 versus cosine of x plus pi over 2, like I said, that needs to be a minus. Since that's a minus, that means your phase shift is pi over 2 to the right. In this case, this one could be written as minus minus, so that means the phase shift is -pi over 2, which means you go that way. That's what you gotta work on a little bit, okay? Because it's a standard form of x minus something, okay? Just think of it this way. If it's a plus, go that way. If it's a minus, go that way.
Well, I did until you wrote -pi and then told me to go left with it.
Well, that's, again, it's a plus, okay? Anytime you do a plus, you're going to go to the left because it's the same thing as minus minus, okay? And you'll get that. You just have to kind of get that in your head as to which is which, Okay, plus is going to be left, minus is going to be right. Okay, so let's move to this next page. We're going to do a couple more things on this, and then I'm going to finish up with a couple more graphs. So the other thing that we want to do on this is if I give you pieces of information like this, I'm giving you an amplitude, I'm giving you the period, and a phase shift, you want to be able to write the function out of that, okay? First thing to probably do on this is let's go ahead and write down the general form. The general form is y equals a, and we're going to do a sine function, so it's going to be sine omega x minus c. I think our textbook, actually, the textbook you guys use, uses a phi a lot. It doesn't matter. It's just whatever variable you want. And then plus c or something like that. All you got to know is what is what, okay? So what you're going to do in this is the amplitude is 3, so of course you're going to plug the 3 in like that, okay? It's a phase shift of 1/2 to the right, so that means the 1/2 is going to go there, like that. That's what the phase shift is, okay? Now, you got to figure out what omega is, and we have a formula for that. Don't just plug pi in there. That's not right to just plug pi in for omega. What you have to do is you have to use this formula. What we learned is the period is equal to 2 pi over omega, right? That's what we've been doing. Well, what did I say the period was in this problem? I said it was pi, so you say pi equals 2 pi over omega, then you solve that equation for omega, okay? Don't put pi in for omega. Use this formula to find omega. Now what are you going to do to solve that equation? You're going to cross multiply, right? Okay, so you're just going to go pi times omega is equal to 2 pi, like that. Then you're going to divide both sides by pi. So what's omega? 2. Okay, good, because the pi's cross out. So what goes in there is that, okay? Now the thing on that is everything's pretty standard on this, except you need to use this formula to figure out what omega is, okay? Now you're ready to write the final answer. So the final answer to this problem would basically go like this. We would say y equals 3 times the sine of omega, which is 2, x minus the phase shift 1/2, and I did not give you a vertical translation, so that is the final answer to the problem right there. So what you're doing is just doing everything in reverse. I've given you the amplitude, I've given you the phase shift, and I've given you what the period is, so that allows you to find omega. Does that look okay? Yes? No?
Yes.
Okay. All right. Everything's pretty standard plug-in like that. And again, what I did on this is, since it's a phase shift to the right, that's why that minus sign's there. If it was a phase shift to the left, what would it say? It'd say plus. Okay, so that's what you got to get kind of straightened out. Okay, the next one's pretty similar. We're going to write down, this is a cosine now, so we're just going to say y equals a cosine of omega times x minus phi, where that's going to be the phase shift, and then plus like c on that. So we're just basically going to plug in everything that we have on this. So I think I gave you the amplitude is 1/3, so that of course is going to go there. The phase shift is going to be, what did that say? Phase shift of 3 to the left. Now what's that going to do to this since it's a left phase shift? It's going to be plus, okay? Right? Now it's always backwards of the way it seems to students. I understand that, but phase shifting left, you got to have a plus sign there, okay? All right, I also said that you're translating up 4, so the 4 is going to go there, okay? Now, if you want to find omega, what do? You use the formula, period equals 2 pi over omega, and then you solve that for omega. So I said in this problem, I said the period is 2, so we're going to solve the equation 2 for the period equals 2 pi over omega. Put that over 1, cross multiply. So that's going to give 2 omega is equal to 2 pi. So what's omega? Going to have that. You're going to have omega equals pi, which is okay. Okay, you've got to solve that equation to find what omega is. So what's going to go there is pi. Okay, that's the hardest part of the problem, is solving that equation. Now the rest of it is just a matter of plugging everything in. then you've got a valid answer to the problem. So the final answer to this problem is going to be y equals amplitude 1/3 times the cosine of omega, which is pi, x, and we said it was a left phase shift 3 to the left, so that's going to be x plus 3. So that's going to say, we're going to say x plus 3 like that. And then it was translated up 4, so it would go like that. So we got everything taken care of. We got your amplitude, we figured omega out, we got the phase shift left 3, and we got the up 4 thing like that. So how's that look? Okay, just doing everything in reverse, that's it. Okay. All right. Now let's go ahead and do like a graph of a cosecant. Since we're really talking about phase shift in this section, that's kind of the key stuff that we need to go through is how phase shifts work. Now we're going to do a cosecant. The first thing that you want to do on a problem like this is you want to put this in a factored form, and the whole purpose of that is so that you'll see what the phase shift is. So we're going to go ahead and, first of all, let's just go ahead and do the factored form. So we're going to have f of x equals 2 times the cosecant, factor out the 1/2, like that, and then figure out what goes inside like that. Now what have you been doing when you take the 1/2 out? You've been doing this. You've been taking the 1/4 pi, and you're dividing it by that coefficient of x. So how do you divide by 1/2 anyway? Times it by 2. So this is really pi over 4 times 2 over 1, which is 2 pi over 4. So that reduces down to pi over 2. So what's going to go there is going to be pi over 2. Okay, and that's a good idea to just check that, make sure it works. Okay, if you factor something, make sure it works. It does. If you multiply 1/2 times pi over 2, it's pi over 4. Okay, now what we're ready to do is identify everything. Now, we're talking about the cosecant. The cosecant, which one did that look like? That's the one that has the U shapes, right? Up U shape, down, up, down like that. Does it have an amplitude? No. Okay, because it doesn't have a max and it doesn't have a min. So don't fall for that. Now, when we graph the sine here in a minute, that's going to have an amplitude, but not the cosecant. I'm talking about what's the amplitude of the cosecant. There never is one. There's only an amplitude for sine and cosine. That's it. Okay? So the period is going to be 2 pi over omega. Omega, of course, is 1/2. So that's just 2 pi times 2. So that's going to be 4 pi. It got stretched. Okay? How do you find the increment? Take the period, divide it by 4. So that means the increment's going to be pi. If you go 1 pi, 2 pi, 3 pi, 4 pi, then you're up to the end of that period like that. Okay, what's the phase shift? Okay, which way? There you go. So it's pi over 2 to the right. Okay, like that. It's got a minus sign. Okay, that's the way it works. Okay, now what we're going to do on this now is we're going to go ahead and we're going to start by graphing out the sine. Okay, really what we got to do is the whole work of this problem primarily is just focusing totally on graphing this sine. So we're going to focus on 2 sine 1/2 x minus pi over 2. Now this time we're going to do this pretty much all in one step. You can learn how to do the graph of that sine with all in one step if you look at it the correct way. Okay? All right, so let's go ahead and just draw a coordinate system on this. And then we'll kind of get this put together. Okay, so the increment on this was pi. So just go ahead and start, counting by pi's. You'll have pi, 2 pi, 3 pi, and so forth. And we'll go out this way, the same idea. All right, now let's think about the y-axis, okay? On this, since you have an amplitude on the sine of 2, you need to be up at least 2, but have a little bit of room so you can sketch in the cosecant. So I would recommend that you just go maybe up to 4 or 5 or something like that, and then maybe go down to -5, like this. Okay, now we're ready to get everything set up and graphed. Okay, now watch how I do this carefully. The phase shift is pi over 2. Now where does a basic sine wave start? It starts at the origin at 0, 0. Okay, so I'm going to do this, pick a color like green or something. Okay, that's where the sine wave starts at 0, 0. It's going to phase shift pi over 2. So it's really going to be halfway in the middle, right? That's pi. Halfway between 0 and pi is pi over 2. So go ahead and just break up these things into little subintervals. That's because we got a phase shift to pi over 2, and that's not on what we did for the increment. It doesn't matter, but you do got to locate where that first point goes. So here's the idea. If you had a sine wave, you start at 0, 0. This thing right here is going to move that point now to there. So that's your first point right there. Okay? All right, now where's the next point going to be on a sine wave? Does it go high or does it go low? It goes high. All right, so what that's going to be, now we're going to be falling on these green things here, so we're going to go there. However, the amplitude's 2, so where's that thing going to go to? It's going to go up to 2 like that. Okay, so that next point's going to go like that. Okay, I start at the phase shift. The next point goes there. Now where's the next point go? Back to the midpoint. Now how about the next point? Y value of negative 2. Okay, and that's good enough. Just kind of dash that in. We don't have any vertical translations or anything, so we have that. And that's as far out as I'm going to go. You can go out further if you choose to. So if you kind of work backwards through the cycle, this one is now going to hit its minimum. Make sure your points line up after what I've got in green there. Then the next point's going to go here, then it's going to hit the high point of 2, then back down to that midpoint or x-intercept like that. And then that will actually be the graph of the sine wave. And see, we did everything in one step. The 1/2 comes from changing the increment of the x-axis. The phase shift came from we started there, and then the 2 was the amplitude like that. So can you guys follow that, everything I did on that okay? Okay, so you can get these graphs. If you kind of go through this procedure like this, then you can get them done pretty easily. Okay, now we have asymptotes. Where did I say the asymptotes fall on these kind of problems? What we call the midpoints, right? Now the midpoints are these things. I'll highlight all these midpoints. That's a midpoint. There's an asymptote. There's an asymptote there, there, and there. So you want to go ahead and you want to draw your asymptotes through that like this now, okay? So now let's go ahead and get the asymptotes put together. It always goes through the midpoints. Don't think of it as x-intercepts, because if you did have an up-down transformation, it's still at the midpoints. So you want to go ahead and get that identified, and then we're going to be ready to just sketch in the rest of the graph like that. Okay? All right, is that good? Now, sketch it. Okay, the rest of us, just sketch in your U-shapes like this. So I'll just do like something like blue. So I think of this as the top of the camel's back. Okay, make it go like that. Make it go like that. Approach the asymptotes. This is the camel's belly. So it's sagging like that. Okay, then it's going like this. And then you can put like a half of a shape like that if you want to. Go like that. So what I did on that is really, I've graphed it over, not quite over 2 periods, but over one period and then a little bit more of another one like that. And that's it. Okay. Now the one thing I do want to do on this problem, I want to do this one more time, is we're graphing now 2 cosecant of 1/2 x minus pi over 2. Okay. Now, one thing that we might want to do on this is just for simplicity is plug in pi over 2 because it's so easy. Now, what is happening at this graph at pi over 2? What's going on? What did I have there? What is that? That's an asymptote, right? So if you went through, and I'm choosing pi over 2 because it's easy. Okay, that's why. I want to see if I do have an asymptote there. So if we plug that in, just for checking, we'd have 2 cosecant 1/2 pi over 2 minus pi over 2. So what that would give is 2 cosecant of, that whole thing would now be 0, like that. Okay, look at your unit circle. when you're at 0 radians, you're at the 0.10. The cosecant is r over y. So what's the deal with the cosecant at this point? It's undefined, exactly, right, okay. That proves that we have an asymptote, okay, so at least that point's right. You could do as many as you want by doing that same idea, and they would all check out, okay, so everything should be correct on that graph, okay. How's that look? Okay, takes practice like anything else, of course. Okay, so that should wrap that up then. I do want, before we go to this 8.1, I do want you guys to write one more thing on this, and I meant to put this on here, is let's do the equations of the vertical asymptotes. And you might want to write this on here. Basically, anytime you have a secant or a cosecant, this formula always works. It's going to be a little tricky to find the asymptotes on these things. But if I want you to find the equations of a vertical asymptote, and this is for a secant and cosecant, it's a little different for a tangent. We talked about a tangent. It goes like this. You could say x equals whatever the first positive asymptote is, plus 1/2 the period, times k, with k being an integer. That formula right there will always give you the equation of a vertical asymptote of a secant or cosecant. Okay, so here's what I mean by this. First of all, the first asymptote we had is at pi over 2. Okay, that is your first asymptote right there. Just take the first positive one, and then we're going to use that. Okay, so that's going to be pi over 2. Okay, then what you do is you say half the period. I forgot what the period is. What's the period? That's at the top of the page. What was that? 4... It was what?
4 pi.
4 pi, okay. All right, so we're going to say 1/2 4 pi times k, with k being an integer. Okay, so when you work the 4 over 2, the way to write this is going to be pi over 2. That right there is going to be 2 pi k, with k being an integer, like that. Now I want to ask you a question and see if you guys understand this or not. Why did I say half the period? That's real important. It helps you remember this. Because if you look at a period, something special happens halfway. Here's a period right here. Right there is one period of that wave. What happens in the middle of it? You have an asymptote. That's why I say the equations of the asymptotes are going to occur. The next one's going to be at half of the period. Does that make any sense? Okay, that's how that works out. So that's a formula you can use. And that will guarantee to give you something that'll work for an equation of the asymptote. Okay, and that's kind of helpful. Okay. Okay, well that will end the graphing. How does that make you feel? Good? Not good? Okay. Well, that doesn't really end the graph. It's going to end what I expect you guys to be able to do as far as graphing. Now, when we get into this 8.1 and start that a little bit here, we're going to do a little bit of graphing, but it's mainly to help you understand a couple of concepts then, okay? Okay, so go ahead and get this set up.